Hi. So welcome to lesson number 2, module 7 of the Big Data and Hadoop Developer course. So in this particular lesson, we will be having a look at the Hive architecture. So before we proceed with the lesson, let's have a quick recap of the previous lesson. So in the previous lesson, we have learned about the origination of Hive and why it was developed, where it is used, what exactly is Hive, and the limitations of Hive. So in this particular lesson, we'll be having a look at the Hive components, architecture, and Metastore. So as you can see from this particular picture, there are 5 main components of Hive. You have a compiler, driver, shell, Metastore, and execution engine. So we will be having a look at each of these components in detail in the upcoming slides. So here you can see a little bit different diagram which actually explains how Hive is working. Now you being a user can interact with Hive either through the shell, which is the Hive command line, or you can interact it through web UI or any tool which can provide a JDBC or DBC connection. Now the main component of your Hive is the Hive driver. This is the part which is receiving your queries and checking for sanity and verifying your queries are correct and then executing them one by one. Now Hive also has something called as a Metastore. So let's see what exactly is this. Now, why do we exactly need something called a Metastore? A Metastore stores information about the tables and databases that you create inside Hive. Now what happens is that when you create a table or a database and when you insert the data, Hive is actually working with the data which is stored as blocks in your Hadoop distributed file system, right? So later point of time when you want to query the data, Hive should know where is the data, which table you are referring to, and what is the relation between all this. So these all information is stored as metadata in something called a Metastore. Now a Metastore has two major components. One is a service called Metastore and a storage space called a database. Now there are three types of metastores available with Hive. You have an embedded metastore, local metastore, and a remote metastore. Let's explore them one by one. So by default, when you download Hive, install and run it, the metastore that you get is called the embedded metastore. Now you don't have to do anything to activate the embedded metastore. It comes by default with Hive. Now here the Metastore service will be running by storing the metadata in the embedded Derby database. So the embedded Derby database is used to store your metadata. Now the problem with the embedded Metastore is that since Derby is a single instance database, it will allow only one user to log in at any given point of time. Meaning if you are using the embedded Metastore of Hive, only one user login is allowed at the time on Hive. You cannot have multiple people logging in. The second type of metastore is called the local metastore. In the local metastore, what you can do is you can have an RDBMS such as MySQL or Oracle to be the backend to store the metadata from Hive. Now here the Metastore service runs on the same JVM as the Hive service, but the database is disconnected and it can be hosted on a separate independent machine. The advantage of this architecture is that you can now have multiple login sessions with Hive. A third possibility is called the remote metastore. Now here what happens is that the metastore actually runs as a separate service outside the Hadoop cluster and the database is also running on a standalone machine. So this is called as a remote metastore architecture. Now let's have a look at how Hive exactly works and what are the different components. So one of the main components of Hive is called a compiler. Now what the compiler does is that if you type a Hive query, it will pass the Hive query and make sure there are no syntax errors. It will also logically analyze the query to make sure that it can return a value or a set of values. Now once the a particular query is analyzed, this will generate an execution plan to execute your query. Now the plan is usually carried out in a direct acyclic graph of stages. Usually there will be a set of map or reduce tasks to execute your Hive query as a plan. Another part of Hive is called an execution engine. Now the execution engine is the component which actually executes the plan created by your compiler. Now by default it has a MapReduce execution engine. This means whatever plan the compiler is creating is being executed as a different map or reduce programs. So here you can see a quick look at how user is interacting with Hive. So the first step is that you type a query and which is received by the driver. Now the moment driver receives the query, the second stage is get plan. It'll send the query to the compiler for the sanity check and make sure that the query is perfect. Now once it understands the query is perfect, the next stage is to get the metadata, because if you want to execute the query, you should know where is the table and what data you are referring to. So you have the get metadata and set metadata, which basically gives you the metadata, and the compiler will send the plan to the driver. Now once the driver has the plan, it sends the execution plan to the execution engine, which in turn execute your query and give you the final result. So here you can have a look at the Hive plus Hadoop architecture, wherein you can see Hive on the left hand side and Hadoop on the right hand side. So in fact Hive sits on top of MapReduce. Now after the execution engine sends their job to Hadoop environment to execute the job, and from that the job tracker takes care of the entire job as discussed in the MapReduce execution flow. So we have job tracker sending it to different data nodes where different tasks are performed like mapper or reducer along with the serial deserializer process. Now the serialization process is basically converted into a binary format whenever data is transferred from one node to another node. And once the entire process is done, your data is read back, the result is read back and presented to the user. So to wrap up, in this particular lesson, we have learned the Hive components, architecture, and Metastore. That's all for this lesson.